Dear friends, in the series of learning gas turbine technology, so we have discussed about heat exchange cycle in the previous class. So in that we have seen about how the performance of the heat exchange cycle works. And okay, so in this class we are going to discuss about another modification. That means for the simple gas turbine cycle we are going to do the another modification. So that modification is going to help us to improve the work. Okay, specifically if you want to say specific work output, okay, how the specific work output is going to be improved. So that is what we are going to discuss. So this modification is nothing but we are taking the turbine outlet. So whatever we have done it for the heat exchange cycle, the same thing here also we are going to do. The turbine outlet we are going to take it, and that one again we are going to send it through the another combustion chamber. So then by doing so, then we are just increasing the temperature. Okay, so the temperature of the hot gases which comes out of the combustion chamber, so then that is again sent to another turbine. So that is what then the turbine again produces work. Okay, so that is how the work is split into two stages. That means in this process, so the turbine work is split into two stages. Two stages to improve the to increase the turbine work. Okay, so by splitting the turbine work into two stages, so then it is increasing the turbine work. So that is okay, very obvious. Okay, from this cycle, especially from this modification. So that is gives in such a way that the temperature, the combination of the temperature, that means that operating points of the first turbine and the second turbine, combination of these two, okay, gives the higher temperature than the normal cycle. Okay, so that is what here we have to understand. So how it is going to help us, that we will discuss. So especially what happened, our turbine T1 and T2, okay, has operating between T3 and T4 and T5 and T6. So this combination so will be higher. That means the temperature, okay, operating between T3 and T4 and T5 and T6. So operating between this temperature will be higher than this temperature. So what we can just say T4 dash. Okay, so we can just draw it in the diagram. So this is okay, so we have just showing it in the TS diagram. So that TS diagram, okay, is very important. So it means yeah, so this is the TS diagram is, yes. So here what happened, it is split into two stages. The turbine is split into two stages. So this is how, okay, now it is like this. So that means this temperature range, you can just say yeah, the temperature range also, this is 1, 2 and 3, 4, 5 and 6. So this is 4 dash. Okay, so it means the in the temperature range, operating temperature range for the turbine 1, turbine 2, that is nothing but 3 and 4 and 5 and 6. This combination of this temperature will be higher than this temperature. So that is what. So what it says, T3 minus T4 plus T5 minus T6. This temperature, combination of these two operating temperature for the turbine 1 turbine 2 will be greater than this T3 minus T4 dash. So that is what, okay. So this thing just we have to understand. So because here only the turbine stages, okay, instead of having this one, we are now splitting into two stages. That is how what happened. The entropy also increases. Okay, so the turbine work is increased in such a way that entropy, because T3 and T4 is operating on one entropy, and T5 and T6, so that is operating at another entropy point. So because of that, okay, our turbine work, okay, increases. Okay, so that is one thing, okay, we have to note down. Because whenever we say that this increases, okay, the entropy increases, so that means there is a heat transfer, and so the energy transfer taking place. Okay, so that is what we have to understand. So this condition must be satisfied for this modification. This modification only we call it as reheat cycle. So whatever we are just doing, that means we are splitting the turbine work into two stages and then increasing the turbine work, and then by that way we are increasing the that means performance of this cycle. That cycle nothing but reheat cycle. So the reheating principle, okay, we are just doing it, okay, here. That means we are just providing another heating chamber, okay, combustion chamber, for heating the energy which comes out of the first turbine. That is, okay, heated by the in this combustion chamber by adding the fuel. That is what, okay, goes to the T2 turbine, 2 second turbine it goes. So that is how, okay, this reheating cycle works. So main thing is, so suppose if you want to have a perfect reheating, so what we want to say, perfect reheating means whatever the temperature operating points at this point, at this point, and at this point. So our reheating, perfect reheating works when T5 equal to T3, because at this point also, at this point, okay, we want to have this condition. Okay, so when we are achieving this condition, T5 equal to T3, T5 equal to T3, then we are just reaching the perfect reheating. So that is what we have to understand. As long as this T5 is T3, T5 less than T3, then reheating, the energy transfer will be taking place. Okay, so when we reach this condition, then perfect reheating is done. Then that is how, okay, this cycle produces maximum turbine work. Okay, so by this modification, what we have to understand, this turbine, okay, produces more work. By the splitting of two turbine produces more work. So that is how, okay, it is enhancing the performance. So that is one thing, okay, we have to understand. So okay, now let us see the operating conditions, so that we have understood from this, okay, how this turbine enhances the that means the reheating cycle enhances the performance of this cycle. Okay, performance of this specifically how the work output, specific work output is okay, increases. So that we can prove it by the that analytical derivation or analytical formulas. So first let us see the this one. So we need to, what we need to do, we have just we have to find out the efficiency for the cycle, how about the efficiency, okay, works. So then based on that we can go for the we can just go for the conclusion how the reheating cycle improves the performance of the reheating cycle. So now in this, okay, what we have to see, this T5, that means specifically what we want to say, the pressure ratio, because this operating points for the first simple cycle operating points have not been disturbed. So we have these points, that means C equal to RT power gamma minus 1 by gamma. So this is as it is, so we are not disturbing. But now, okay, since we have another two turbines, so for that we are providing this one. So it means this works in such a way that we say C equal to C1 into C2, means not C1 into C2, that means pressure ratio RP RP only split into this one, RP1 into RP2. So this is okay happening here. So because of the splitting, so we just we are concluding like this. So RP equal to RP1 into RP2. So based on this we can write C1 means C1 equal to, we can write RP1 whole power gamma minus 1 by gamma. So this is nothing but RP1, okay, this is happening between this T3 by T4. This is the operating temperature for the first turbine. So that is what, based on that we are writing C1. Then C2, it is based on the turbine 2, that is RP2. RP2 whole power gamma minus 1 by gamma, that is equal to T5 by T6. So this is nothing but T5 by T6. So T3, okay. So now we got it. See, that means from based on this combination, okay, this formula, that means reheating works in such a way that RP, that turbine is split into two stages. So based on that we are writing this condition, RP equal to RP1 into RP2. Based on this only we are writing this one, C1 and C2. Then okay, once we, okay, if you are able to write this, then based on this we can write C equal to we can write C1 into C2. So this is one thing, okay, we have to note down. So this is, so based on this, okay, definition, and based on this pressure ratio and this one, now we can find out the specific work output, and also we can find out the efficiency. So the efficiency, how it works, we'll see. So based on this formula, how it is going to work. So now, okay, let me just draw the this. Okay, so our specific work output, that means formula, first of all we have to write the compressor work equal to Cp. That means if you say Cp, that we can write H2 minus H1, that is equal to Cp into T2 minus T1. Then turbine work T1 equal to, so that operates between 4, okay, 3 and 4. So H3 minus H4. So this is okay, this is always okay, higher minus lower. That is what, okay, here we have to write. So Cp into T3 minus T4. Then WT2 equal to H, this is okay, H5 minus H6. So H5 minus H6, so Cp into T3, yeah, that means not T3, T5 minus T6. Okay, so we have written the turbine work. Then similarly we have to write the heat supply, QS equal to QS1 means this one, based on this one. So based on this one we are writing, based on the first combustion chamber. So that is operating point nothing but H3 minus H2. So that is equal to Cp into T3 minus T2. Then another one, QS2 equal to next 5 minus 4, that means H5 minus H4. So that is equal to Cp into T5 minus T4. Okay, so this is what these are the operating ranges. Okay, that means turbine work and compressor work and heat supply. So based on this only we need to derive the formula for specific work output. So that is okay, we can do it, and also based on this only we can find out the efficiency. How we are going to do this, just we will do it now. So here our turbine work, okay, so that means net work is nothing but Wn is nothing but Wt minus Wc. Okay, so Wt is okay, here we have a Cp, this we have to take it together. So nothing but Cp into T5 minus T3 minus T4 plus Cp into T5 minus T5 minus T6 plus, okay, this is a total turbine work minus compressor work. So Cp into T2 minus T1. So this is what, okay. So based on this only we need to find out the this one. So what we used to do, we used to take that means T1 outside from this formula. So if you take a T1 outside, then it becomes Cp into T1 into T3 by T1 minus T4 by T1 then plus T5 by T1 minus T6 by T1 then minus, okay, minus T2 by T1 by T1, the last one plus 1, okay, this. So this is what, okay, so this is what, okay, we have to understand. So now, okay, in this we are going to split this one. This term is going to be split, that Cp into T1, that T3 by T1 we know that is nothing but T, okay, so that did not change. So T3 by T1 is same as it is, we'll see. Then minus T4 by T1 only we are going to split, that means T4 by T3 into T3 by T1. So this one we are splitting, plus T5 by T1. So T5 by T1, so we are just going to take it as this one for the perfect reheating. So this one T5 will be equal to T3, okay. So this one, okay, we have to understand. So this temperature has been replaced, okay, in T3 minus T6 by T5 into T5 by T1. This is then plus then this temperature, this one. So now, okay, you can just rub this, yeah. So plus T2 by T1 plus 1, okay. So this is how it is going to change. Now Cp into T1 into T3 by T1 nothing but T minus T4 by T3 okay, we have seen nothing but 1 by C1. So 1 by C1 into T3 by T1, there is nothing but T minus T3 by T1 plus T3 by T1 nothing but T minus T6 by T5, this is also 1 by C2 into T5 by T1. So this is for the perfect reheating. This pipe becomes T3 by T1, so nothing but T, then plus T2 by T1 nothing but C, okay. So that is, okay, we have seen T2 by T1 nothing but C, then plus 1, okay. So this is what, okay, this is what WN. So now everything we have replaced, okay. So we have replaced this one, okay, we have to just make it. So for the from this we need to find out the maximum work, okay. So this one, okay, WN equal to this one. So then this formula, okay, what happened for the maximum work, okay, we need to for finding the maximum work, then we need to differentiate these terms, okay. We need to differentiate these terms, and then before that we have to simplify this. Wn equal to Cpt1 into this one, you can write T plus T, we have a 2T, then minus this one T by C1 minus T by C2. So we can write T by C1 minus T by C2 is, then we have a plus C plus 1, okay. So this is okay, plus C plus 1, okay. So this one, okay, we want to maximize, so that case we have to go for the differentiation. So for maximum work, for maximum maximum specific work we can say. So maximum specific work, so okay, that means, so specific work nothing but Wn by Cpt1. So this one D by D C3, so we are going to, sorry, C1, okay, C1 into this one. So our maximum turbine work nothing but is so WN by Cp T1. This is what equal to 0. So by doing the differentiation, and then we are getting this formula. Okay, so this formula comes around, that means by doing this, then we will be getting C1 equal to root C. Okay, so when we say C1 equal to root C, then will be C2. This is also equal to C2. Okay, so before differentiation, what we need to do, we need to change C2 into C1. Okay, because we know C equal to C1 into C2. So from this, okay, we have to change C2 equal to C by C1. So this one, this substitution we have to do it here. Okay, this assumption, no, this one we have to substitute here, then we have to do the differentiation, then we will be getting we will be achieving this condition, C1 equal to root C, that is also equal to C2. Okay, not this one. Okay, so this is also equal to C2. So once we get C1 and C2 equal to this one, then that one we are going to replace. Okay, we are going to replace. So that one, okay, we can just say that how the maximum work. Okay, so that now we can just say as the maximum work by this one, Cp T1, that is equal to this condition. So 2T minus T by C1, T by root C minus T by root C. So plus C, okay, plus 1. So this is what, okay, after doing the differentiation and then getting the condition, after substituting this, we are getting this. So this, okay, again we can write W max by CPT1 equal to, that is okay, 2T minus 2T by root C plus C plus 1. So this is, so okay, so this one we got it. So now, okay, we have to just do the one symbol, this one. So this one, let it be. We need to find out the efficiency now, that means heat supply. So our heat supply is nothing but Qs equal to Qs1 plus Qs2. So that is equal to, we know, Cp into T3 minus T2 minus plus Cp into T5 minus T5 minus T4. Okay, so this is, so this has to be okay, this also we need to do the same thing. We are taking T1 outside, then T1 by T3 by T1 minus T2 by T1 plus T5 by T1 plus okay, minus T4 by T1. Okay, so by this one, okay, we need to simplify. So how we are going to simplify this one? So let's see, just yeah, so by simplifying this, by simplifying this, okay, we will be getting Qs. So Qs equal to CPT1 into T3 by T1, nothing but okay, T3 by T1, so minus T2 by T1, that is also fine. So we have the substitution, this plus T5 by T1, that is also we have. So then so we can, because for the perfect we are getting T5 nothing but T3 by T1 plus this minus T4 by T3, this one we can replace, T4 by T3 into T3 by T1. So this one, so here we can substitute this one. So CPT1 into, this is nothing but T minus T2 by T1, nothing but C, plus T3 by T1 T, then minus T4 by T3, nothing but T4 by T3, 1 by C1 plus okay, into T. Okay,